Okay, so in this slide we are going to take a look on periodic function, and we should with the help of a short trick or with the help of a simple strategy we can find the period of a function without taking the aid of graph. So a function is said to be periodic if it satisfies this following functional equation: f of x plus t equals to fx for all x belongs to the domain of the function. Okay, now here t is a positive real number, t is a positive integer, and this t is the smallest interval that we are talking about. So by default, period of a function we mean the fundamental period. Here t represents the fundamental period. Fundamental period. We are mainly interested in finding the fundamental period of a given function. A given function may have more than one period, but we are mainly interested in fundamental period of that function. A function can have infinite number of periods, but we shall investigate the fundamental period of that given function. For example, if we considered sin x, okay, if we consider the graph function sin x, here f of x plus 2 pi sine of x plus 2 pi, this actually gives me sin x. Again, if we replace 2 pi by 4 pi, then also we are getting sine of x plus 4 pi. This is also sine x. So 2 pi, 4 pi, 6 pi, these are all the periods of the given function, but the fundamental period is 2 pi. 2 pi is the fundamental period. So t equals to 2 pi is the fundamental period of this function sin x. Now this we can actually verify with the help of graph, but we shall make use of a short strategy to find to investigate the fundamental period of the function. This 2 pi, 4 pi, 6 pi, these are all the period of the function, but the fundamental period is 2 pi, and we are mainly interested in finding the fundamental period of the function. So if we draw the graph of sin x, let me draw the graph of sin x. Okay, so 0, this is pi, this is 2 pi. So actually this length represents the period of sin x. After this interval, the graph of sin x will repeat itself. So 2 pi is the fundamental period of the function. After this, the graph will repeat itself. So this is the fundamental period. Now and this can be easily determined using the graph. But we shall make use of another strategy to find the period of sin x. Now we have already stated that f of x plus t is equal to fx for all x belongs to the domain of the function. This is very important, that x must belong to the domain of the function. Now consider the function of sin x once again. We have f of x equals to sin x. Now we shall make use of another strategy to find the period of this given function. Now for that we should place x equals to 0 in the given functional equation. Let this be 1. We should place x equals to 0 in the functional equation 1, then provided 0 is in the domain of the function, otherwise we cannot make use of this strategy. So we get f of t equals to f of 0. But we must take care before applying this short trick that 0 is in the domain of the function, then only we can apply this rule. Okay. So to determine the period of sin x, we should make use of this functional equation. Okay. So we have f of t equals to f0, so imply sin t equals to sin 0. This gives us sin 0 is 0, so t will be n pi. Because sin x is 0, we know that on the horizontal axis sin x is 0. On the horizontal axis sin x is 0, and the equation of this horizontal axis is n pi. So we have t equals to n pi, where n is a positive integer. N is a positive integer. Because t is always positive, so here we have n is a positive integer. Now we need to place a check to determine the period of the function for n equals to 1, 2, 3. Okay. Now f of, just a minute, okay, now we have for n equals to 1, at n equals to 1, at n equals to 1, we have t equals to pi. So first we shall place a check for n equals to 1. Now sin fx equals to f of x plus pi equals to sin of x plus pi, and this gives us minus sin x. So it doesn't satisfy the equation f of x plus t is equal to fx, where x is the argument and t is added to that argument, then we get the same function once again. So this functional relation, this functional equation is not satisfied for x equals to pi, for t equals to pi. So we need to place another check on this. At n equals to 2, at n equals to 2 we have t equals to 2 pi. So sine of f of x plus 2 pi equals to sine of x plus 2 pi, and this gives us sine x once again. So from here we do not need any further check, we don't need to check further, and this tells us that 2 pi is the period of the function. So this is a handy approach to determine the period of a function. Okay. Now we can use this technique to determine the period of a more complex function. For example, we know that period of sine x is pi. This is the fundamental period. Fundamental period. Fundamental period of sine x. If we draw the graph of mod sine x, and similarly here 0, pi, 2 pi. So period of modulus of sine x is pi. Here fx is sine x, mod sine x. And we can also observe from the graph that period of cos x is also pi. Definitely the fundamental period. So if we draw the graph of mod cos x, and similarly so period is also pi over here. Period is pi. Now an important point to note over here is that suppose this is our function fx and this is our function gx, and if we construct a new function, let it be hx, sum of these two functions, then it is said that although the period of each of this function is pi and pi, but on addition we are getting a new function, its fundamental period may not be pi. Fundamental period of hx, fundamental period of hx, fundamental period of hx fundamental period of hx may not be pi. This is not guaranteed. Now, definitely pi is one of the period of mod sin x plus mod cos x, but we should check that whether pi is the fundamental period or not. That we need to check. So we can use this strategy above that we have just discussed to determine the fundamental period of this function mod sin x plus mod cos x. Okay, so let me erase this first, and we shall place a check to determine the fundamental period of mod sin x plus mod cos x. Okay, so we have hx equals to mod sin x plus mod cos x. Okay, now we should make use of that short trick ft equals to f0, provided 0 is in the domain of the function. 0 must be in the domain of the function. Here we could see that 0 is in the domain of both sin x and cos x. So we can apply this approach or technique to get the desired result. So h of t will give us mod of sin t plus mod of cos t. And h of 0 will be mod sin 0 plus mod cos 0. Okay, imply mod sin t plus mod cos t equals to 1, because we have 0 plus 1 over here. Sin 0 is 0 and 0 plus 1, that is 1. Now mod sin t is positive, mod cos t is positive, so we square on squaring we get mod sin t square, mod sin t square plus mod cos t square plus 2 mod of sin t mod of cos t. So this gives us 1 plus mod sin 2t. Okay, so that implies therefore 1 plus mod of sin 2t equals to 1, implies mod of sin 2t equals to 0. Now mod sin 2t is 0, that implies, like we know from the properties of modulus function, mod of x equals to 0 will give us x equals to 0. So sin 2t will be 0. Now sin 2t is 0 implies that 2t should be equal to n pi, because on the horizontal axis sin x is 0. So from here we get 2t equals to n pi. That implies, okay, let me erase this part. we get 2t equals to n pi. That implies t equals to n pi by 2, where n is a positive integer. Now we need to place a check. So at n equals to 1, we have t equals to pi by 2, and for consecutively we will check one by one for n equals to 1, 2, 3, etc. until and unless the equation gets satisfied. F of x plus t should be equal to fx. Okay, so we have mod of, we have our hx x plus pi by 2 is equal to mod of sine of x plus pi by 2 plus mod of cos of x plus pi by 2. Okay, now we could see that although sine of x plus pi by 2 is minus cos x, but due to the presence of mod function, it will be at the negative sign will be absorbed, so we are getting mod of cos x plus mod of, similarly we are getting mod of sin x, but this is our fx, that is our hx. So we are getting the same function hx on replacing x by x plus pi by 2. So the period of this function is, the fundamental period is pi by 2. So the fundamental period of mod sin x plus mod cos x is pi by 2. This is the fundamental period. Pi is definitely one of the period of mod sin x plus mod cos x, but pi by 2 is the fundamental period, and we are mainly interested in finding the fundamental period. So we conclude that fx and gx would have the same period pi, but it doesn't guarantee that fx plus gx should have the period pi also, should have the fundamental period pi. Their fundamental period, the period of mod sin x plus mod cos x, its period is pi by 2 and not pi. This is the fundamental period. Pi is definitely one of the period. Okay, so by making use of this trick without determining the graph of the function, we can also find the period of the function. Definitely graph is a smarter approach, but with the help of this technique we can find the period of a given, fundamental period of a given function. And thanks for watching.